Hi, good morning. Take a look at the problem. JEE 2026, 21st January, shift to F from R to R. F from R to R. That means real number to real number, and it is twice differentiable. Twice differentiable means F dash X exists as well as F double dash of X is also exists. That is the meaning of twice differentiable. And also saying F double dash of X greater than 0 for all X belongs to R. What this means? Second derivative is greater than 0 for all X belongs to R. That means F dash X is also F dash X is a F dash X, or also you can write second derivative as d by dx of F dash X greater than 0 for all X belongs to R, which implies the function F dash X is increasing function. What it means? It is increasing function. That is the meaning of F double dash of X greater than 0. Okay? For all X belongs to R. And also, they gave like F dash A minus 1 equal to 0 for where A is real number. For any real number, they are talking about F dash X, F dash of something is equal to 0. Here this value is replaced by X. Okay. So for X is equal to A minus 1, it will be, for X is equal to A minus 1, the derivative F dash X is 0. Okay. So there it is getting maximum and minimum. Or, okay. And if F dash X, if X is smaller than A minus 1, since F of X is, F dash X is increasing. Remember, F dash X is increasing and X is below of A minus 1. Of course, it is F dash X is below 0. And for X greater than A minus 1, for all A belongs to R, and also F dash X is increasing function. We already claimed that F dash X is increasing function here. So that F dash X is greater than 0. Okay, these are all the conclusions we are getting from this equation. F dash X is equal to where A is real number. Okay. And the options are as follows. What are the options? So what are the options? You can see here the options also. G of X is increasing in this interval. G of X is decreasing in this interval. Statement 1 and statement 2. The first option is neither 1 nor 2 is true. Only 1 is true. Both 1 and 2 are true. And only 2 is true. So this is the scenario we have to. So now we observe that below A minus 1, it is f dash x less than 0, and above a minus 1 it is greater than 0. Now what is g of x? Because options are completely contains g of x. Look at the g of x function. Take the g of x function. G of x function defined as f of tan square x minus 2 tan x, tan square x minus 2 tan x plus a plus a. And it is from 0 to 90. Here the x belongs to 0 to 90 for g of x. Okay. For f of x, x belongs to R. We can take anything. Okay, let us consider the internal part. There is an internal function. Take that one as u of x. Okay, some internal function. So that will be tan square x minus 2 tan x plus a. Here clearly it is visible to, we can write as a quadratic equation. So u of x, we can write tan x minus 1 whole square plus 1 and minus 1 are added, then it is possible. So u of x will be tan x minus 1 whole square plus a minus 1. Okay, this a minus 1 is interlinked with here. Okay, everywhere. Where a is any real number. Okay, since this is increasing, it is positive, right? It is positive. And a minus 1 is also positive. A minus 1 is also positive. Okay, a minus 1 is also positive. So overall, u of x is clearly a positive value. U of x is increasing function. So now we'll conclude like this. G of x is equals to f of u of x. F of u of x. Whereas g dash of x, because we have to identify whether increasing or decreasing in certain intervals. Okay. So that's why find out g dash of x, and then we will examine whether it is increasing, decreasing, what's happening there. Okay. So g dash of x is nothing but f dash of u of x multiplied by u dash of x. That is equal to, and clearly f dash is increasing everywhere. We already confirmed that fact. So f dash, I'm keeping that f dash u of x is same. So now the increasing and decreasing nature completely depend upon the value of u dash of x in the two intervals 0 to pi by 2 and pi by 2 to pi by 4. Let us examine that. Okay. So what is u dash of x? Let us calculate u dash of x, which is 2 times of tan x minus 1, and the constant part is 0. And here tan x derivative secant square x. Okay. So we will copy this value here. 2 into secant square x into tan x minus 1. Clear? So this is increasing. Okay, can I indicate increasing nature as upward direction of an arrow? So 2 is also positive. Secant square for all x belongs to R, it is also positive. No. And it will be defined in the interval 0 to pi by 2 in the first quadrant. In the first quadrant, all are positives. We know that, right? In trigonometry. Now, this value decides this value decides the sign. Sign means here increasing or decreasing. Okay, let us go with this X, this G. Okay, case 1, we will discuss like 0. It was given 0 less than X less than pi by 2. This will be split into two parts, first part and second part. So first part is 0 less than X less than pi by 4, because here 1 will indicate pi by 4. Okay. And after that, pi by 4 less than X less than pi by 2. Okay. So in this scenario, in this case, tan x minus 1 is in this scenario, is it positive or negative? Negative. Negative means this implies g dash of x is negative. That means g dash of x is negative means decreasing. Decreasing. In this case is decrease. This case is decreasing in this interval. In this interval. Okay. So what was they saying? They're saying increasing. Look at this. They're saying increasing, which is false. Right? So it is not correct. This is not correct. Let us move on to the next part. Now again, we will examine tan x minus 1. What happens in this interval, pi by 4 to pi by 2? So of course it is positive, because more than pi by 4 means, of course, tan x is an increasing value under first quadrant. Okay. We know the graph will be looks like this, tan x graph, right? From pi by 4 to it is increasing, right? So more than 1 means it is positive. So positive, which implies that g dash of x is greater than 0. That means it is increasing. Yes or no? But here they are saying in this particular, it is decreasing. So the wrong statement they mentioned. Okay, clear is it? So neither 1 nor 2 is true. Yeah, option 1 is correct for this question. Okay.